So question 3 says solve the following logarithmic equation. So what I'm saying again is using the properties of logarithms, since this is addition, I could put this together as a single logarithm. So I'm gonna rewrite this problem down here. So the log of x, that's a base 10 logarithm, plus the log of x minus 48 base 10 is equal to 2. So it's a good idea to go ahead and identify the domain restriction here. So notice how this has to be greater than 0. Then also x minus 48 has to be greater than 0, which means x has got to be greater than 48. So if I look at this on a number line, you have to meet both conditions. So you got to be greater than 0, and you got to be greater than 48. To be greater than 0 and greater than 48, you actually have to be greater than 48. So our domain restriction then is x has got to be greater than 48. So if we don't get a number greater than 48, then we will have a null solution. So as we move through this problem, since this is a sum, we can put this back together as a single logarithm using multiplication. So this becomes the log of x times x minus 48 base 10 is equal to 2. Since it's a single logarithm, we can use exponential form again. So remember, the base is actually a 10, and the 2 is the exponent. So the 10 squared go together, and then that's got to equal then this x times x minus 48. So if we multiply this out, we're picking up on that this is going to be x squared minus 48x. This is a degree 2 equation, and that's going to equal 100. So to me, we have to set this equal to 0. So that's going to be x squared minus, this should be 48x there. X times negative 48 is negative 48x. So x squared minus 48x, subtract the 100 over, is equal to 0. So what are the factors of 100? Actually, I have to have a negative 100, but I have to add up to a negative 48. So I know there's a 1 in 100, and there's a 2 and a 50. That 2 and 50 already looks pretty good to me, but the 50 would have to be negative. So 2 times negative 50 does give me negative 100, and 2 plus negative 50 does give me my negative 48. So this is factorable. So we are getting, so x plus 2 times x minus 50 is equal to 0. So if I set each one of these linear equations equal to 0, that's that multiplication property of 0. So if this is a negative 2, notice that a negative 2 would make this equal to 0, because negative 2 plus 2 is 0, and 0 times anything is 0, so that would be a true statement. X minus 50, what makes that 0? Well, that would be 50. So 50 minus 50 would be 0. So if I put a 50 in there, that's going to work. So remember, based on our domain, x had to be actually greater than 48, so the negative 2 actually drops out. Our only solution would be the 48. I'm sorry, the 50, since it's greater than 48. So if I wanted to check it, if I put that into the problem, the log of 50 plus the log of 50 minus 48, does it give me 2? Yeah, it does check. Now, if you try that negative 2, notice that the log of negative 2, that already is going to crash. That's going to give me an arrow, so it's not going to work out. So that negative 2 is going to get rejected. So the only solution to the original equation is the 50. Now, the negative 2 satisfies this equation, but you got to remember that this is not the original equation. This was the original equation.